Now we're going to talk about simplifying, multiplying, and dividing rational expressions. And you know a rational expression is simplified when there are no common factors in the numerator or denominator. The main thing you're going to be doing is factoring. You automatically factor in these problems, and then it's very, very simple. So again, if you can factor, this is no big deal at all. So a rational expression is just a fraction, and so all of the rules of fractions that you learned about way back in 5th grade are still the same, and they still apply when you're dealing with rational expressions. You know, rational expressions look a little bit more complicated because they are, polynomials instead of just integers. But again, everything is exactly the same. So let's refresh our memory on just fraction rules. So for instance, if you had a fraction 3 over 9, this would not be simplified. And you would say, well, I know I can divide the top and the bottom by 3, and the answer is 1/3. Now that's simplified. But what you're really doing here is you're breaking each of these into its factors. Okay, and so you're saying, well, really the numerator is 3 times 1, and the denominator is 3 times 3, and then I can cancel these 3's, and now I'm left with 1 over 3. Okay, and so this is a much better way to think about what we're going to be doing when we're just simplifying, because you really need to factor everything and then cancel like factors. So let's do a couple of examples of those. Okay, when you're asked to simplify something, the first thing you make sure you understand is that you have to cancel all factors for it to be simplified. If anything, if any factor is shared between the numerator and denominator, you have not simplified it. The other thing to keep in mind is that you should automatically factor. Do not do anything until you factor. All right? And if you can't cancel a whole factor, you cannot cancel. Okay? So we're going to just check. This is factored, but this is not. So let's break that down. X plus 3 stays where it is. The denominator is difference of squares. So that factors to x plus 3 and x minus 3. X plus 3 and x plus 3 cancel. We'll cancel the whole factor, not just part of it, the whole thing. And we're really left with a times 1 up here, so make sure you understand that. And so the numerator is just 1, and the denominator is now x minus 3. Now that's simplified. There is no factor shared in the numerator and denominator. Okay, we're going to simplify this rational expression. And again, you're always going to start off factoring as far as you can. Do not do any canceling until you have factored both the numerator and denominator completely. So you have to remember all of those rules of factoring. And the first one should be seeing if you can factor out a GCF. And I'm looking here at the numerator, and I notice that there is a GCF of 2x. So I'm going to take that out. And what I'm left with is 2x squared minus x minus 1. And now I'm going to go ahead and check the same kind of thing in the denominator. And the GCF there is also 2x. So I'm going to take that out in the denominator at the same time. Now you don't have to do this all at the same time, just as long as you do it all. Alright? Now I'm going to check to see if I can factor anything here in the numerator. We have this trinomial. And so I'm going to go through the steps of factoring here. And maybe you want to do it off to the side, and that's fine. So, how do you factor this? Well, you can do the A times C method. Right? This one isn't too bad just to set up, because we only have so many factors that we can get. Right? But again, if you're having trouble factoring, that's something you want to clean up real quickly. Okay, 2x times x is 2x squared. 2x times negative 1 is negative 2x, plus a positive 1x gives you negative x and 1 times negative 1 is negative 1. Okay, so that is factored. So then our numerator is 2x times 2x plus 1 and x minus 1. And that's all over 2x and x minus 1. Now again, you're canceling whole factors. If you're not sure what a factor looks like, that's something else you better get cleaned up before you tackle these kind of problems. But they both have a 2x, so those are canceled. They both have an x minus 1, so those cancel as well. Now there's nothing left to cancel, and we have 2x plus 1 as our simplified answer. Okay, here's another rational expression to simplify. And again, you're just starting off and factoring right away, every time. Okay, and I'm going to do these all together, numerator and denominator. Numerator is difference of squares, real easy to factor, right? Okay, and again, maybe you want to do the denominator off to the side here. No greatest common factor to factor out. So we're going to do the a times c method. 2 times negative 2 is negative 4. And we're going to rewrite that as 2x squared minus 4x plus x minus 2. And we're going to group the first 2 and the second 2 together. Take out a 2x out of the first one. We're left with x minus 2. Take a 1 out of the second one. Left with x minus 2. And so that will factor into 2x plus 1 and x minus 2. And so we're going to write that in our denominator. These are equivalent. And now we're looking for any common factors. You can't factor anything else on here any further. And you're going to cancel whole things, whole factors, x minus 2 and x minus 2. And then there's nothing else that is a common factor. So now we're done. And our answer would be x plus 2 over 2x plus 1. Before we go on, I want to caution you about canceling. Some people get carried away and they just start canceling all kinds of stuff that doesn't get, that can't be canceled. You can only cancel factors. So for instance, if you have x plus 3 over x, this is not factorable, but for some reason people say, oh look, there's an x there and an x there, so the answer must be 3. No, no, no. Do not do that. You could not go any further than x plus 3 over x. That would be done. Okay, and likewise, you cannot do something like this. You can't look at this rational expression and say, ooh, look, a 2 goes into 4 twice, and so my answer must be 2x plus 3. No, these are not factors. You cannot do that. You would just be done here at 4x plus 3 over 2. Nothing else. Again, don't get carried away. You just see some like numbers and think, oh great, I'm going to cancel. No, no, no. Right? You cannot just cancel 5s randomly. Right? 5 plus x is the factor, not the 5. So you would have to cancel everything here. So this is not something you want to do. Okay? Don't try to tell me that this is 1 over x. You're crazy. No. The final answer would just be 5 over 5 plus x. You're done. So be careful when you cancel. Don't get carried away. If you haven't factored yet, you should not be canceling anything. Okay, so let's remember our rules for multiplying fractions. Okay, so for instance, let's have 2/3 times 12 over 7. Okay, our rules say that we had to multiply straight across. So we do that and we would get 24 over 21. And now we check to see if there's anything that we can simplify. And both of these, the numerator and denominator have a factor of 3 that we can factor out and cancel. So this would be 3 times 8 over 3 times 7. The 3's would cancel, and you'd be left with 8 over 7. Okay, so that works just fine for what we're going to do as well. But I think the safest thing to do when dealing with rational expressions is just factor everything right off the bat. Okay, and so let's think about what would have happened if we took this same example and factored right away. 2 and 3 don't really do a whole bunch, but we could rewrite 12 as 3 times 4. And now you say, well, you could factor 12 in a bunch of different ways. But what's nice about doing it at 3 times 4 is that we have this situation where we have the same factor in the numerator and in the denominator. And you might say, well, they're in 2 different fractions, so how's that help? If you remember that you can multiply in any order, then that allows us to cancel these 3's right away. And then when we multiply straight across, we have 2 times 4, which is 8, over 7. Okay, and so now we have the same answer, but we factored and canceled first on the second example, and then multiplied, or we multiplied and then factored and canceled. Okay, so for rational expressions, it's going to be much easier to do it the second way. So basic rule when you're having 2 fractions multiplied together, 2 rational expressions multiplied together, is factor everything. If you find the same factor in the numerator and the denominator of either fraction, then they can be canceled. So let's do a couple examples of those. Okay, so for our first example on multiplying rational expressions, always just start factoring, and then this first fraction, there's nothing that we can factor. So we're going to leave that one alone, but both numerator and denominator in the second fraction can be factored. So I'm just going to recopy the first fraction, and now we have difference of squares, so x plus 2, x minus 2, and then in the denominator we have plus 2 and minus 1. And now we're going to look for anything that can cancel in the numerator and denominator. Okay? And it doesn't really matter which one we cancel here, because you can notice that we have an x plus 2 and an x plus 2. Only one of these can be canceled because we only have one in the denominator. So again, it doesn't really matter which one you cancel. I'll just cancel these 2. And then we glance through, and there's nothing repeated. No factor in the numerator shows up in any of the denominators. And so we can just say that x plus 2 times x minus 2 over x minus 3 and x minus 1, that's done and simplified. I guess you could FOIL these if you wanted, but this is pretty simplified here. And so I would suggest just leaving it like this. All right, for this next example, I want to point out a situation that you may come across, and that is a polynomial that's kind of not set up the way you're used to seeing it. I always prefer my variable first when I'm factoring. And maybe you're okay with this, but you may have to deal with this situation anyway to get things all the way simplified. And you're allowed to manipulate these in ways that are within the rules. And so I'm just going to take out a -1 out of both of these so that it's a little bit more what I'm used to seeing. And now we'll still have to factor this further, but as long as this -1 is part of our answer, you're allowed to do that type of thing. So we still have to factor this difference of squares, and we still have to factor this difference of cubes. And anything big, you're more than welcome to do on the side, and that's what I'm going to do with this difference of cubes. Because I like to figure out what all of my numbers are. It makes it a little bit easier for me. Okay, and so we're still going to use SOAP like we were doing before. And so a cubed minus 1 will factor into this. Right? Our same sign, opposite sign, always positive. So now I'm just going to rewrite that and then copy everything else down. Now, of course, I'm going to factor this numerator. It's a difference of squares. That's going to be pretty easy. And again, I'm going to look for things to cancel here. And again, make sure you're canceling whole factors. And anything in any of the numerators can cancel with anything in any of the denominators. So I'm going to cancel the a minus 1s. And then, I'm also going to cancel this a squared with the a to the 5th. Just be careful and don't forget your exponent rules. Right? We're canceling all of that. And then when we cancel that, we still have 3 a's up there. And so nothing else can be factored. Don't forget about our negative 1 here. And so our final answer would be negative a cubed times a squared plus a plus 1 all over a plus 1. Okay, so for the final part of this section, we're going to talk about dividing rational expressions, and I want to remind you of the rules of dividing fractions. So if we had 2/3 and we're dividing that by 5/12, the very first thing you do when you're dividing fractions is you flip the second one, and then it becomes a multiplication problem. So this is really 2/3 times 12/5. Now you can do your factoring. Okay, and so this is the same as 2/3 times 3 times 4/5, and we can do that so that we can cancel these 3's. Nothing else can cancel, and so we're left with 2 times 4, which is 8/5. Okay, so the only difference between this and the multiplication is that before you do anything else, you better flip this fraction, and then make sure you also start multiplying. So let's do a couple examples of those. Okay, so make sure that your first step when dividing is to rewrite this as a multiplication problem and using the reciprocal of the second fraction. So this would be x minus 2 over x plus 1 times x minus 3 over x plus 5. Now we're going to look for things to cancel, but you will notice, since this is a multiplication, anything in the numerator could be canceled with anything in the denominator, but there is no like factors. So we're just going to combine this into one fraction. Make sure you add some parentheses around these factors because they're grouped together. And that would be our final answer. Okay, so this next example is again a division problem. The very first thing you need to make sure of is that you flip the second one. So I'm just going to rewrite this before I do anything else as a multiplication problem. Alright, and now I'm going to factor anything that I can. Alright, the first denominator, there's nothing to factor there. And the second numerator, there's nothing to factor there. But these other two should be able to be factored. So I'm going to go ahead and do that. A squared minus 1 is the difference of squares. So that becomes a plus 1 and a minus 1. Over a minus 1. And now we still have a plus 1 in the numerator there. And we're going to factor this denominator. And again, if you need to do it off to the side, that's great. That's what you should get when you factor. Now, everything that's in any numerator can be canceled with anything in the denominators. And so we're just going to go through and we say, well, here's an a plus 1, but there's no other a plus 1, so we can't do anything with that. We have this a minus 1 that we can cancel, and it doesn't really matter which a minus 1 you cancel. And there's nothing else that we can do on this one. So we're going to rewrite this, just multiply straight across. We got a plus 1 times a plus 1 over a minus 1 times a minus 1. And that's a fine answer. You know, you can leave it like that. Or you can say, well, I have like bases that I'm multiplying together, so I can add the exponents. And so maybe a more simplified answer would be a plus 1 squared over a minus 1 squared. But either of these answers are simplified just fine. Okay, so again, very important to flip the second fraction before you really get too far. And so I'm going to just rewrite this. And I'm going to factor everything I can. Okay, and everything can be factored at least a little bit. The first numerator there, you can take an a out, and you're left with a squared plus 4. And then you have a difference of squares, so we have a plus 4 and a minus 4. Now the numerator here is also factorable. We have a plus 5 and a minus 4. And the denominator is factorable also, to plus 5 and plus 3. Alright. Again, if you need to factor those off on the side, that's perfectly fine. Now we're going to cancel anything we can. So I see an a minus 4 that we can get rid of. I see an a plus 5 that we can get rid of. And that's it. You know, just be careful. These are not the same. You can't cancel anything about those. And so when we multiply straight across now, we have the numerator of a times a squared plus 4. And then a plus 4 over a plus 3.